What I'm going to talk about today, partly on the board here, I've basically, what I set out to do is I wanted to give some tips and advice for people who would basically are either interested or are currently creating educational content for others. I think there's always a demand for more teachers. However, I find some teachers do things better than others. So I'm not saying I'm the best at this. I'm not saying I'm necessarily an expert. But what I do have experience in is I've written several ebooks. I have created over, I think, 250 videos at this point. Created an entire course on Kotlin and taught myself to program. I don't have a degree in anything. And yeah, so over the years, through spending literally thousands of hours doing those things, I've come to figure out a couple general purpose tips for how to create good educational content. Now, one of the things about this is you have to understand different people are going to have different advantages. So one of my unfair advantages is that since I don't have a degree and I teach myself, I don't actually generally have to rely on jargon or technical information or technical definitions and those sorts of things. I usually tend to understand and explain things through my own understanding. And yeah, as someone who doesn't spend a lot of time actually talking to programmers in my day-to-day life, I actually spend more time explaining programming to people who aren't programmers. That gives me a bit of an unfair advantage in simple explanations. Anyways, what I'll do is I'm just going to dive into my 3 rules. Great job, Ryan. Here, I'll count German style there. 3 rules for creating better educational content. So, rule number 1. Use jargon as sparingly as possible. And this is especially true if you are teaching beginners. So let's talk about jargon very briefly. And so what I'm getting at here is that very, very often the jargon you use, the technical big words, can actually, especially for beginners, cause more problems than they solve. Especially if instead of using the jargon term, you find a term which is familiar to people in everyday life or is can be easily conceptualized by your students. So in order to explain what I'm talking about here, one of my favorite topics in programming, and I talk about it all the time, is testing, the subject of testing. Because when I started with testing, I looked up the Android documentation back in like 2016, and the documentation for Android has gotten way better, so I'm not just crapping on the Android team. The documentation is way better now. But back then, it was terrible, because you would look up the documentation, and it would say, here's how to do an instrumented test. Here's how to do unit testing. Espresso is for testing the user interface. Here's how to do integration testing. And then we had all these different things. We had unit testing, instrumented test, we had acceptance tests, we had integration tests, we had, I think, functional tests was another one that was mentioned. We had end-to-end testing, black box testing, and not all of those things were described in the documentation, but basically what would happen is the jargon term would basically be a stand-in for some topic that I was absolutely unfamiliar with. I didn't even know what a unit test was. I didn't know what an instrumented test was. So, how do we avoid this problem of relying on jargon and assumed knowledge? The first thing you can do is to, and this also kind of bleeds into the next thing that I'll be talking about, is to actually just not really use jargon or try to avoid it as much as possible, and to instead rely on the simplest kind of analogy or the simplest code examples which you can think of. So, for example, if I were to introduce the topic of testing to beginners and then I throw out a whole bunch of jargon and assumed knowledge and use this API and use that API, and I think should you do roboelectric, should you do Mach K, run JUnit tests, all this kind of crap. If I want to actually introduce the topic of testing to beginners, then I start with a very simple explanation. So here we have a very simple code example. So here we have, this is an article I wrote on testing, and in order to actually explain the concept of testing, in absence of all the jargon and all the assumed knowledge other than basic programming skills, then I write a really simple program which basically a simple test suite which tests a simple program that I have. So in this case, we're just testing a binomial expression calculator. And I won't spend too much time here, but in order to actually test what it does, so we have this kind of object, which is a calculator. And so how do I actually make sure that this object, or it could be a function, is behaving the way it should, that it works, that it's well formed? I give it some data, and then I see what the result is. I see what it does with the data. How do you test a rocket? Let's say you're responsible for designing the next SpaceX rocket, which will fly into the air and refuel the International Space Station or whatever, give them supplies. How do I test, say, for example, a component of this rocket? Maybe I should say ship. So maybe I want to test one of the thrusters, the rocket thrusters. Well, if I want to test that thing, then I'll build a copy of it, and then I will try and fire it. You do what it's supposed to, have it do what it's supposed to do in different scenarios. Maybe when the weather is super cold, maybe when the weather is super hot. And what I'm talking about is related to the Challenger disaster in history. I think it was in the 70s, where the Challenger space shuttle, I hope I'm getting that name right, flew, attempted, I forget exactly what the mission was, but they were flying into space, and unfortunately the shuttle exploded, killing everyone on board, and it was found out by eventually a combination of by talking to the engineers and a particular military general, who I unfortunately forget his name, and the scientist Richard Feynman, that the O-rings, the gaskets in this rocket, did not behave as they should at close to freezing temperatures, and when they launched the rocket, it was close to freezing temperatures at the launch pad. So it doesn't matter if you understood what I just said here, but what I'm talking about is testing. So how do we test some object or calculator or some kind of class? We give it a bunch of data. So here we have these different test scenarios. And I don't need any libraries to do this. Now, oftentimes I do use libraries, but here we're just testing what our calculator does by giving it a bunch of data. By calling evaluate test, give it the data we want, and then what we do is we figure out if the result equals some expected value. So what we're doing here is we're saying we're test firing the rocket, and if it doesn't explode, then we've figured out that our rocket behaves well in a given scenario. If it does explode, we've figured out, okay, this thing is not really designed and working 100% properly. So I didn't actually mean to explain testing in such detail, but this is how my brain works. But what I'm trying to get at here is I just tried to explain testing, a topic which is really difficult for a lot of people, without using the word unit test even. Because at the end of the day, there's a big difference between using big confusing words and actually knowing how to test your code. So anyways, that's number one. Use jargon as sparingly as possible.